All right, my fellow Euclidean geometrists, I am recording a lesson for section 4-3 in your textbook, Geometry Concepts and Applications. 4-3 starts on page 156. In Braille, where we want to be is 156A, and it starts out saying when a transversal crosses two lines. So find 156A. If you need to pause the video, do so. So on 156A, and at the top of your page in print at 156, there is a graphic, a drawing. And before that drawing, it has a paragraph of information. It says, when a transversal crosses two lines, the intersection creates a number of angles that are related to each other. We've kind of learned that. In the last section, we learned about vertical angles and alternate interior angles and alternate exterior angles and consecutive interior angles. Just flat out interior angles. Those are in the inside of the lines that the transversal crosses. Note that angle 7 and angle 8 below, although one is an exterior angle and the other is an interior angle, both lie on the same side of the transversal. So they have a drawing down below with two lines running west and east with arrowheads on each end. There is not an arrowhead in the midst of the line anywhere, so we know that they're not parallel. We have another line again running west to east, east to west. It's slightly skewed. Skewed means that it's not quite horizontal. And we have a transversal going through, cutting through both of those lines. That's running from about 11 o'clock to 5 o'clock. So this should look familiar. I've been working with these the last two sections. Definition of a transversal is a line that intersects at least two lines at two different points. The top line they've labeled line M, and the bottom line line L, and our transversal is labeled T. And they're saying note angle 7 and 8. So angle 8 is the top right exterior angle, and angle 7 is the bottom right interior angle. And it's saying note that they're on the same side of the transversal. Okay? So angle 7 and angle 8 are called corresponding angles. They have different vertices, and they're on the same side of the transversal. So we're going to get to a postulate about corresponding angles of parallel lines. But the biggest thing to remember to identify corresponding angles is one's going to be on the exterior, one's going to be on the interior, and they will be on the same side of the transversal. Okay. So we have a bunch of corresponding angles in this particular graphic. They just haven't labeled them for numbers for us to identify. 7 and 8 are corresponding. So turn a couple pages, and it's going to give an example. One of lines P and R are cut by a transversal T, and we need to name two pairs of corresponding angles and then name the other two pairs. So first, let's get really familiar with our tactile, our graphic. We have line P at the top of our graphic that's running from 9 o'clock to 3 o'clock, or 3 o'clock to 9 o'clock. All right. Got our two arrowheads. We do not there's not an arrowhead in the midst of it anywhere, so we know it's not parallel to anything. They've labeled it line P off to the bottom right. Then if you look below, feel down below, it's starting at about 10 o'clock position in its orientation, and going through about the 4 o'clock position is another line, and that's line R. They're saying P and R are cut by the transversal T. So there's another line, T, running from about 1 o'clock to 7 o'clock. That's our transversal, T, and they've labeled T the top left of the arrowhead. And then where it intersects, where line T intersects line P, they've labeled the 4 angles there. Angle 1 is top left, and then it goes clockwise. Angle 2, angle 3, and angle 4. And then where line T intersects line R, in the bottom part of our drawing, we have labeled angles, the interior 5 and 6, and the exterior 8 and 7. If we go clockwise, looks like they went 5, 6, and then 8, 7. Okay, I didn't quite go in numerical order on that one. And they are asking for 2 pairs, let's just do all of them, of corresponding angles. There's actually 4 pairs. So corresponding angles, we got to have one on the outside, one on the inside, one on the exterior, one on the interior, on the same side of the transversal. So let's find our transversal. And to the left of the transversal, we have 1, 4, 5, and 7. And to the right of the transversal, we have 2, 3, 6, and 8. Our exterior angles are 1 and 2, and then all the way down to the bottom, and 7 and 8, because exterior means on the outside of the 2 lines that are getting intersected, cutting through. The interior would be on the inside of our lines being transversed, and we have interior angles of 3, 4, 5, and 6. So our corresponding angles have to be on 1 exterior, 1 interior, on the same side of the transversal with different vertices. So if we pick number 1, we have to then go down to the other vertices, and we have to choose 5. 1 is on the exterior, 5 is on the interior, same side of the transversal. 1 has its own vertex, 5 has a different vertex. So 1 and 5 are corresponding. If we stay down below in the 5 area and we go to the other side, went down, we find number 7, just below 5, that's an exterior. So its corresponding would be 4, because it's on the interior and a different vertex. Go to the other side of your transversal, the right side of your transversal, all the way up to the top, and you have an exterior angle 2, so its corresponding angle would be on the interior at the different vertex, so that would be 6. 2 and 6 are corresponding. And then 8, which is just below 6, is an exterior angle, and its corresponding angle would be 3. So 8 and 3 are corresponding. So those are all called corresponding angles. They have, the definition is they have to have a different vertex. One of the angles has to be on the exterior. One of the angles has to be on the interior. And they have to be on the same side of the transversal. They're not alternating. Okay, they're corresponding angles. So that's good practice to identify those. Let's turn the page and read some information. This says, as with interior and exterior angles, there is a special relationship between corresponding angles when the transversal intersects parallel lines. So remember when we learned some theorems in the last section about parallel lines in the transversal, that alternate exterior angles are congruent, alternate interior angles are congruent, and consecutive angles are supplementary. Now you're going to learn about special relationships of parallel lines with corresponding angles. It says, recall that in lesson 4-2 you discovered that if parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent, and that each pair of consecutive interior angles is supplementary. Using the drawings you made from the hands-on geometry, blah, 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 blah. We're not going to do that. We didn't do that. So let's turn to postulate 4-1. So 2 pages over in your Braille, at the bottom of your page on 156, there's several drawings. And Braillers, we're going to have 3 drawings in a row that we need to look at. And then or actually 4 drawings. And then we'll discuss our postulate. Now our postulate actually is back 1 page on 156E. So let's read that first. Postulate 4-1 on 156E says, if 2 parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. Each pair of corresponding angles is congruent. So we turn the page and we take a look at this. Every time we'll see that each pair is congruent by the drawing. So we have a pair of parallel lines. They're slightly skewed to each other, or not skewed to each other, but they're not horizontal, running diagonal. But you notice that you have your parallel arrow indicator in the midst, the extra arrow indicator on each line. They're running from about 10 o'clock to 4 o'clock. And each one that's parallel to each other in their little clock face areas. And then running from 12 o'clock to 6 o'clock is our transversal, cutting through those 2 parallel lines. And they've identified that the top left angle, exterior angle, it has a tick arc through it. And then the interior angle on the left, bottom left, has a tick arc through it. Those are corresponding, one exterior, one interior, different vertices, same side of the transversal, and corresponding angles of parallel lines cut by a transversal are always going to be congruent. Their measures will be equal. Okay. The next drawing, so print users, we're just looking at 4 drawings in a row. Braille users, we have another page for the drawing. You have the same 2 parallel lines, and same orientation, with your parallel arrow indicator in each one of them. And then they're got the transversal also running from 12 o'clock to 6 o'clock, so similar drawing, similar tactile. Now they've labeled a different set of corresponding angles and showing that they're congruent with 2 tick arcs. So the angle on the top right, the exterior angle, has 2 tick arcs, and then the interior angle on the same side of the transversal has 2 tick arcs. So those 2 are corresponding because they're on the same side of the transversal, different vertices, one exterior, one interior, and the transversal is cutting through parallel lines. So these are corresponding angles and they're congruent. The next drawing shows the next set. A set of parallel lines. Take a look at that. Same parallel lines again. And same transversal. And they're identifying an interior and exterior angle, and they're showing congruency with 3 tick arcs. Remember, we just match arcs to arcs. So, drawing my transversal. Oh, they forgot the arrowhead on that one. Transversal. All right, the interior would be to the right of your transversal in the top. The interior has 3 tick arcs. And then the exterior is bottom right, and it has 3 tick arcs. It's showing that those are 2 corresponding angles, and they're congruent. Okay, corresponding angles of parallel lines are congruent. And then finally, the last drawing shows the last pair of corresponding angles. So we have our transversal going from 12 o'clock to 6 o'clock, cutting through our 2 parallel lines running from 10 o'clock to 4 o'clock in each of their little separate vertices and clock face positions. And we have our little extra arrowhead showing that they're parallel. And then the bottom left exterior angle has 4 tick arcs. Can you feel that mess? Is it 4 or 5? I have 1, 2, 3, 4, 5 tick arcs on this one. Craziness. I don't know why they did 5. And then in print, it's just a big old mess. It's hard to make them out, but there's a bunch of them. So we have 5 tick arcs. Okay. So bottom left exterior, and then top left interior. Those are congruent. They're corresponding angles. 1 exterior, 1 interior. Separate vertices, same side of the transversal. So they're corresponding. And corresponding angles of parallel lines cut by a transversal are always congruent. Their measures are always equal. Okay. So turn the page, Braille users. Print users, we're now on page 157. Braille users were on 157. We're going to do some practice with an example of a drawing. Let's make out and see what this drawing's all about. It says in the figure, line L is parallel to M, so it's giving us that. Remember, parallel is EDL. and then line A is a transversal. And then we also have a line B that's also a transversal, it looks like. They're just not naming that. So we have 2 transversals going on here, which is pretty cool. And the transversals are actually parallel to each other, so that's interesting. So let's make out the drawing and see what's going on here. So we have a top line running from 9 to 3 that's labeled line L. So find that and take a look at that. You have an arrowhead on the left. Then you have 1 arrowhead about in the middle, so you're like, aha, an extra arrowhead. That's going to be parallel to another line, probably directly below it with an extra arrowhead. So go directly below and find that line. You find that line, and it's running from 9 o'clock to 3 o'clock. It's got its extra arrowhead in the middle, so that means 1 extra arrowhead corresponds with the other extra arrowhead, and those are parallel. And this is line M. And they've labeled that slightly to the right of the arrowhead. Then notice that we have 2 transversals, one on the far left, and they've labeled it line A down in the bottom left-hand corner. It's running from about 11 to 5 o'clock. Now, can you make out that in the midst of that there are 2 arrowheads right in a row? Because they already used 1 arrowhead, we have to use 2 arrowheads here if we have another line that's parallel to something different. So that 2 arrowheads in the middle indicates it's parallel to something. It's going to be parallel to another line with those 2 arrowheads in the middle. So follow it to the right, feel either to the left or right. In this case it's to the right, and you're going to find another line with 2 arrowheads in the midst of it. And those 2 lines then are parallel to each other. That's the code of the drawing, is to look for those 2 little arrowheads matching each other. So we actually have a transversal situation going on here in 2 different ways. These 2 parallel lines that are running from 10 to 4 o'clock are transversing line L and M. This line to the right is line B. And the lines AB that are running from 10 to 4 o'clock, they're parallel to each other, so they're being transversed by L and M. So we actually have 4 transversals going on here with these 2 sets of parallel lines. Kind of cool. What we want to focus on then is now they've labeled all the angles that are being created. So start in the top left where line A is transversing L and M, and the very top left angle is angle 1. And then let's go clockwise around that vertex point of that intersection, and we have angle 2, angle 7, and angle 8. So they've labeled the top left corner angle 1, angle 2, angle 7, and angle 8. Follow that transversal down to the 4 o'clock position, and they've labeled those 4 angles around that vertex point where the transversal is intersecting, where A is intersecting line M. And the one starting to the left is angle 9. And then we go clockwise and we have angle 10, angle 15, and angle 16. Okay, so 9, 10, 15, and 16. So there's all our angles on that transversal. Go to the transversal on the right, line B, transversal B. Still running 10 to 4 position. Up in the top, so top right area, are a bunch of angles. I'm going to start at angle 4 and go clockwise, 5, 6, and 3. So we have 3, 4, 5, and 6 in our top right, around that vertex. Follow that transversal down to the bottom right-hand area, where line B intersects with line M at that vertex. And we have angle 11 on the interior, angle 12 on the exterior, angle 13 on the bottom right exterior, and then angle 14 on the left of that transversal. So 11, 12, 13, 14. So we have all of our angles. Whew, whole lot of stuff going on here. That's what it takes to do geometry, is you got to really just pay attention to your drawings and make out everything that's going on and really understand it. You already have a whole bunch of information in your head about all this information that's going on. The two lines intersecting, just looking at where two lines intersect at a point, you know about vertical angles. You know about linear pairs. You know that linear pairs are supplementary. You know that vertical angles are congruent. Okay? Now we know about exterior angles and interior angles. Our exterior angles are 1, 2, 3, 4, 13, 14, 15, and 16. That's the exterior angles that would be considered if A and B are our transversals. Okay? If we flip it and we look at it where L and M are our transversals of A and B, then our exteriors change to 4, 5, 12, 13, 1, 8, 9, and 16. But let's just look at it in this orientation. So our exteriors are 1, 2, 3, 4, 13, 14, 15, 16. Then our interiors, starting at the left, we have 8, 7, 6, 5, 12, 11, and 10, 9. I'm going kind of clockwise on the interior. Those are interior because they're on the inside of our lines being transversed. Now, our corresponding angles, those would be the ones that we have an exterior and an interior on the same side of a transversal, different vertices. So if you go all the way over to the left, we have several going on here. Angle 1, exterior. Angle 9, interior, different vertices. Both of them are on the same side of the transversal, so 1 and 9 are corresponding. They are congruent, because we just learned postulate 4-1. Corresponding angles of parallel lines are congruent. Angle 8 is an interior. Angle 16 is an exterior. Same side of the transversal, different vertices. Those are corresponding. They're going to be congruent. Now that should make sense. If 1 and 9 are congruent, let's say they're 60 and 60, we know the measure of number 8 because it's linear to number 1, and linear means that they're supplementary. They have to add up to 180. So we could subtract 60 from 180 and we know number 8 is 120. So of course it has to equal its corresponding angle, number 16, because number 9 is 60, and 60 minus 180 is 120, and 9 is the linear pair to 16. So it's proving it, isn't it, using some of our prior knowledge. Angle 2, up in the top, right of that first transversal, corresponds with angle 10 on the interior. Angle 7 corresponds with angle 15. If you move over to the right transversal, you probably already started figuring out your corresponding pairs. Angle 3 corresponds with angle 11. Angle 6 corresponds with angle 14. Angle 4 corresponds with angle 12, and angle 5 corresponds with angle 13. So it's pretty cool, isn't it? And because really line M and L are also transversals of A and B, if we turned our book to face us if we turned it 90 degrees and looked at our drawing that way, A and B now are parallel and they're going from about 8 o'clock to 2 o'clock. And then L and M now are the transversals of that, and they're parallel. We just again created or are seeing that we have corresponding angles that are congruent because of the parallel lines. So now if we put our brains on, we realize that all of the angles on one transversal and parallel lines are equivalent to all the angles on the other transversal and parallel lines because the transversals are parallel themselves. That's pretty cool. So we could learn that we could be told the degrees of just one angle, and we could label the degrees of all the other 15. If we were told angle 1 is 60, that's top left. So turn your book the other way again, turn it right side up. Angle 1 is top left. If we were told that was 60 degrees, then you know angle 2 is 120, correct? Because of supplementary angles and linear pairs. You also know angle 7 is 60 because of the vertical angle rule, but also you could still continue with your linear pair rule. 2 and 7 are a linear pair. So if 2 is 120, 7 is 60. And that matches with vertical angles are congruent. If 7 is 60, 8 is 120, or 8 is the vertical pair with 2. So we have 60, 120, 60, 120. Then those all correspond with their pairs down below. So 1 and 9 are equivalent, so 60, 60. And then we go around the circle again, 120, 60, 120. And then if you turn your book 90 degrees, you start identifying that L and M are the transversals of A and B, well, now you can transfer those measurements back up to 3, 4, 5, and 6, and 11, and 12, and 14, and 16. Those are all 60, 120, 60, 120, 60, 120, 60, 120. Pretty cool stuff, huh? Just by knowing one angle. So you'll have to do that in your practice. You'll be asked, okay, you're given an angle, measure what are the measurements of the rest of the angles. All right, let's turn the page, and we're going to do a thus far, kind of summing it all up, and the concepts and the types of angles. So a little bit of a concept review. And there's a table in print that talks about these. And it states, pretty sure it says, let's see, do concept. Oh, actually, concept review is going to be on the next page. Concept, let's see, is it concept review? Types of angles. We're looking for concept postulates. Oh, okay, they showed the proof of these things. Great. All right, that's what they're showing is the proof. And then you got little letter A for your turn. Yeah, that would be on the next page. 157B, your turn, and then little letter B, little letter C. Then they say thus far. So there we are on page B157, about the middle of the page. 1, 2, 3, 4, 5, 6, 7 lines down. Thus far, you have learned about the relationships among several kinds of special angles. And it does a concept review. The types of angle pairs formed when a transversal cuts two parallel lines. So congruent are alternate interior, alternate exterior, and corresponding. And supplementary are consecutive. So they're same side of the transversal on the interior. Those are consecutive angles. They're just one right after the other. They're going to be supplementary. All right? Okay, and then it also then turn the page. It says you can use corresponding angles to prove the relationship of a perpendicular transversal to two parallel lines. And in the figure, R is parallel to S and transversal C is perpendicular to R. So let's take a look at our drawing. So we have line R, which is our top line. It is running from 3 o'clock to 9 o'clock, and it has an extra arrowhead in it. So we know that that's going to be parallel to something. We feel directly down below it. We're looking for the parallel line running in the same direction into infinity and never crossing. And we have line S, and we're even given that in writing, that line R and line S are parallel to each other. And then line C, we're told, is the transversal, so that's running from 12 o'clock to 6 o'clock. And they're labeling that line C up the top right. And then they use the little right angle indicator in the top right angle. They only have to use it once. They label that angle 1, and we know that that's 90 degrees. And now we tap into our knowledge about perpendicular lines. And when they intersect another line, they create a 90-degree angle. And what are the measurements of all the other degrees? 90, 90, 90, correct? And because these are parallel lines, now we tap into what we know about a transversal and parallel lines, and alternate exteriors and interiors and corresponding angles and their congruency. Well, okay, if we're going to have 90, 90, 90 up here, that perpendicular line is also going to be perpendicular to the line below it. We're going to have 90, 90, 90, 90 all the way around that one. You have an angle labeled angle 2. So they write a little bit of a proof on the next Braille page, and this is in print in blue writing on your print page at the bottom of page 157. It says angle 1 is a right angle. And why is that? Well, definition of perpendicular lines. We tap into that definition. The measure of angle 1 is 90 degrees, and that's the definition of a right angle. We learned a long time ago that right angles are 90 degrees. And then the angle 1 is congruent to angle 2 because of postulate 4-1, corresponding angles are congruent. And angle 1 is exterior, angle 2 is interior, and they're on the same side of the transversal with different vertices, so they're corresponding angles, and they're of parallel lines cut by a transversal, so we know they're congruent. So we know angle 1 is equal to angle 2. Well, the measure of angle 1 equals the measure of angle 2 because of the definition of congruent angles. If they're congruent, then they have the same measure. And we can use substitution. We can say, well, we know the measure of angle 1 is 90, so we substitute that in for the measure of angle 1, and we say, hey, that equals the measure of angle 2. So therefore, angle 2 is a right angle by definition of right angles, so C is perpendicular to S also. So if C is perpendicular to R, it's got to be perpendicular to S. So there's an example of a proof all the way through. Okay? Then we get to a page break in Braille at 158. And so then this relationship leads us to the following theorem, and this is theorem 4-4, perpendicular transversals, and it should make sense. I mean, we just proved it, we're thinking about it, we're writing it down. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. It doesn't take a turn and all of a sudden become not perpendicular. It's a line and has to extend in both directions into infinity and stay on the line. It doesn't break and skew off. Then it's an angle, isn't it? It becomes two rays. So if the line's going to intersect at one point at 90, it's going to intersect at the other parallel line at 90. All right? So they have another figure, a final example of the day, and it has an algebra link to it. Of course, we always got to have an algebra link. So they say in the figure that line P is parallel to line Q, and transversal R is perpendicular to Q. If the measure of angle 2 equals 3x minus 6, find x. So you know, you're looking at your drawing, you're seeing you got two parallel lines running from about 10 o'clock to 4 o'clock in each of its little clock positions around its vertex. All right, and those are your lines that they're saying are parallel to each other. They've got the little extra triangle. They told it to you in writing also that P is parallel to Q. And then line R is the transversal, and they also gave you the symbols and told you in writing that it's perpendicular to P and Q, and you have a little right angle indicator on there too, so find all those. And then they're labeling angle 2. It's the exterior angle down on the bottom left. And they're saying if angle 2 is 3x minus 6, find x. Well, what do you know about angle 2? How much is the value of angle 2? Well, based upon our new, perpendicular and corresponding rules and all that stuff, well, everything's 90 on this. So angle 2 is 90 degrees. So you got to make 3x minus 6 equal to 90. Do some basic algebra. Add 6 to both sides, divide by 3, and discover that x is 32. And if you plug it back in, you better get 90. Right? So then they have you do some extra practice where they say, now it's your turn. What if the measure of angle 2 is 2 open paren x plus 4? Now this is where you got to bring up your skills of remembering the distributive property. 2 open paren x plus 4 close paren means that you got to distribute that 2 to the x and the 4. So you actually have 2x plus 8. And now you're going to make it equal to 90. Do some big pre-algebra, really. And use your subtraction property, use your division property of equality, and solve for x. Right? And that is the end of section 4-2. For extra practice, either you'll come to class and we'll be working for the check your understanding, or you can do this on your own, and at least you should do page 158 to 159, number 1 through 12 for extra practice. Number 3 asks you to draw a pair of parallel lines cut by a transversal. That might be a little difficult. If you're braillers, you could get out your draftsman and do it using a straight edge and a protractor, but we can discuss those. But mostly do 1, 2, and then 4 through 12 for extra practice. All right, that's it for section 4-3. I might have said 4-2 earlier, sorry. Section 4-3, transversals and corresponding angles. And we'll move on to the next session in the next section, in the next video. Have a good one.